What's going on, everyone? You're back with quick math, and today we're going to be looking at compound interest in the real world. So what often happens is that the time periods are a little bit different. So if you're investing in stocks or on the share market, most companies on the ASX, instead of paying you out once per year, they actually pay you out twice per year, which is awesome. In the last video, we saw that if you increase the principal and everything else remains the same, you make more money. So the more times we have these compounding periods, the more money you're going to make if you are investing in something. So when the compounding periods increase, so if N increases, that actually changes the R value. We get the same rate for the whole year, but because it's compounding more frequently now, we have to reduce the rate to match it. We've got to make sure that for the whole year, the R value kind of stays the same. So we will see this in a couple of examples, but here I've just got written down, if you're compounding twice a year, the 4% rate that you might get becomes 2% twice. This is still good for you because the principal increases on that second one, but it doesn't mean you're getting 4% twice a year, which would be way better. So if we have a look at this example, we're going to compare what happens between the normal yearly compounding and if we get extra compounding periods. So for this one, the principal is our $7,000. We get 1 plus 0.08. And because we're compounding twice a year, we divide this by 2. Because we're not getting 8% twice, we're getting 4% twice. But a really quick shortcut is to divide it by the amount of compounding periods we're going to have. And then we multiply this by N. So we know that our N is 5, but we're getting it twice every year, so we multiply this by 2. If we throw that into our calculator, we get $10,361.71. So we've made $3,000 in 5 years, which is pretty good. We're just going to compare this to our normal, right, compounding annually. So in this one, we've got 7,000, 1 plus 0.08 multiplied by 5. Throw that into the calculator, and we get $10,285.30, which is about $80 less. Again, when we're talking about these small amounts of money, right, small amounts of money, the difference doesn't look that big, but over time and with greater amounts, it becomes really, really important. So the big hint and the big shortcut for these ones is whatever you divide the rate by, you've got to times the power by. So these two numbers should always be the same, always be the same. And that will just help you kind of know that you're on the right track. Unfortunately, this can work the other way. So instead of making more money because the compounding frequency goes up, if you've taken a loan and the compounding frequency is really high, you have to spend more money. And there's no better example than this than credit cards. So credit cards actually compound daily. So every day you owe the bank money, they start charging interest that day. And then whatever you owe the next day, interest goes on top of that as well. So people in Australia with credit cards on average have $4,200 worth of debt, which is not good at all, right? There's I'm a big fan of the Barefoot Investor, who says that credit cards aren't necessarily needed in day-to-day life, but it is just something you have to decide for yourself, but just be careful when you sign one of these contracts. So a really common interest rate for these is about 20%, right? And that's per annum, but you're getting charged per day. So all we've got to do is type into our formula to see how much money we're going to have to pay the bank if we're not on top of our debts. So in this one, we've taken our average Australian debt. 1 plus 20% is a huge rate, but that's 0.2024. And we know that it's being compounded daily, so we've got to divide that by 365, okay? Then we've got this debt for 2 years. So we go 2 multiplied by the 365 because it continues to rack up like that. If we type that into the calculator, we get $6,295.10. So in 2 years, you owe an extra $2,000, right, just because of interest. If we compare this to what happens if it was compounded just yearly, like the 20% per annum kind of suggests, we'll see that that's equal to 4,200, 1 plus 0.2024 multiplied by 2. Chuck that into your calculator, that's $6,072.22. So in this example, you pay an extra $200 because the bank has decided to compound daily. Seems like a bit of a scam, right? And even though it's only $200 in this example, if there's millions of Australians that are in this debt that's compounding every day, the bank does end up earning quite a lot of money. So that is just something to be careful of before you kind of finish school and get your first credit card, is just check the terms and conditions, make sure it's not too over the top, and have an understanding that that compound interest is going to happen every single day. Thanks very much, guys, and I'll see you later. I hope you guys found that helpful. Just a reminder that there are some free worksheets attached in the description below relating to this very topic. I also put up a PDF of the notes so you don't have to copy them from the video. If you do need any additional help, please don't be scared to send me an email. And don't forget, subscribe to the channel for some more quick math.